Welcome to The Explainer. Today, we're diving into something that feels a little bit like magic, how recommendation algorithms seem to predict our every move, and why they're getting so accurate.
You know that feeling, right? You're scrolling through an app and it suggests something that's so perfect, it's almost spooky. Well, we've all been there. And the answer to how it happens lies in a really powerful idea called sequential recommendation.
So at its heart, the idea is actually pretty straightforward. The system just looks at the chain of things you've already clicked on, or watched, or bought, and it tries to guess what's going to come next in that chain. This is the engine that powers so much of what we see online, from movie suggestions all the way to product listings.
But, okay, here's the real problem. Your history on an app isn't some neat, clean story. It's usually a long, messy, chaotic jumble of clicks and views. So how can an algorithm possibly find the important signals in all of that noise?
I mean, just think about it for a second. To predict what you're going to do next, should the system look at just your very last action? Or maybe the last 5? What about the last 100? For years, engineers tried to tackle this by building models that were supposed to act like different kinds of human memory.
So let's take a look at the two classic old-school ways of doing this. You can think of them as kind of flawed attempts at creating a digital memory, and you'll see pretty quickly why they struggled.
And this slide just lays it all out, right? You've got this huge trade-off. On one side, you have these things called Markov chains. Think of them as having only short-term memory. Super fast, super simple, but they totally forget about your long-term interests. And then on the other side, you have recurrent neural networks, or RNNs. They try to process your entire history step by step, but they get totally bogged down by all the irrelevant stuff, which makes them incredibly slow and clumsy.
So it turned out that neither model was a silver bullet. Researchers basically found that one worked okay on what they call sparse data sets. That's where users have very little history, while the other one worked a little better on dense data sets, where you have tons of user data. This fundamental problem is what really pushed them to say, okay, we need something completely different.
And that is where this breakthrough model comes into the picture. It's called SASREC, which is short for Self-Attention Sequential Recommendation.
This is the big idea, right here. Instead of processing everything in order like an RNN, or just looking at the very last thing you did like a Markov chain, SASREC uses something called self-attention. It's like a search engine for your own personal history. It can instantly scan everything you've ever done and pull out only the most relevant actions for what you're doing right now, and it just ignores all the noise.
And what was so clever about this, so genius, really, was taking a technology that was a massive success in understanding the language of human sentences and applying that same idea to understand the language of our behavior online. It was just a brilliant conceptual leap.
So, how does this thing actually work? Well, to put it simply, it's a 3-step process. First, an embedding layer turns your messy action history into a clean, numerical format that a machine can actually read. Then, the self-attention block does its magic, scanning that history and figuring out which past actions matter the most for the next prediction. And finally, the prediction layer uses that focused information to give you your recommendations. The absolute key here is that it does all of this at once, in parallel, not one by one, which is what makes it so incredibly fast.
All right, so the theory sounds impressive, but does it actually work? How does this new approach really stack up against the old models out in the wild?
Well, the results are pretty darn clear. When they tested it on the famous MovieLens dataset, which is a standard benchmark for this kind of work, SASREC just blows past the competition. It significantly outperforms a leading RNN model and another popular type, a CNN model, in accuracy. It's just better at picking the right movie. And get this, it's not just about accuracy, it's also way faster. Because of that parallel design we talked about, the research showed it can be trained over 11 times faster than a similar model. That is a massive advantage.
But accuracy and speed are really only part of the story. Here's where it gets really interesting. The true genius of this model is its adaptation, how it intelligently changes its whole strategy depending on the kind of user you are.
So on those sparse datasets, let's say for someone who only occasionally buys beauty products, there's not a lot of history to go on. In this case, the model learns to act just like one of those simple Markov chains. It pays a huge amount of attention to the very last thing you looked at because, hey, that's the strongest signal it's got. But now check this out. On a dense dataset like MovieLens, where a user has rated hundreds and hundreds of movies, the model completely changes its strategy. Here, it acts like a perfect, super efficient RNN. It learns to look deep into your past to find that movie you rated 5 years ago that's actually really similar to the one you just watched.
It's smart enough to combine both short-term and long-term signals.
Okay, so let's pull all this together. What's the bottom line here? What's the big takeaway from all this?
The takeaway is that SASREC isn't just a small improvement. It's a genuine game changer. It gives us a combination of accuracy, speed, and intelligence that was just out of reach with the old models. And there's a huge bonus. It's more interpretable. We can actually look inside the model and see why it made a certain recommendation, which is a massive step forward for developers.
So, the next time you're scrolling and you get one of those spooky good recommendations, the one that makes you think, how on earth did it know I wanted that? Well, now you know. This is the science behind that feeling.
Which really makes you wonder, right? As these systems get this good at predicting what we'll do next, what does the next level of personalization even look like? That's the question driving the next wave of innovation, and we'll be here to break it down when it arrives. Thanks for watching.